We're going to talk today about graphing tangent and cotangent, and then our reciprocal functions, right? We already talked about sine and cosine. You guys should be good with that. We're going to go over some stuff. You'll see here in a minute to review a little bit. But your test review, I'll post later on today. You have a test on Thursday. You guys are going to have a web assign to do Wednesday. Tomorrow in class, I'll let you work on it, ask some questions. But guys, web assign is not good preparation for your test. Right? Your test is going to be 5 questions, and it's just going to say graph. So you have to identify the amplitude and the phase shifts and vertical shifts and time periods, stuff like that. So just picking multiple choice questions on WebAssign is not good preparation. That's why I gave you guys extra practice for 4.5, and I'm going to put the test review up sooner than later, okay? What you need to remember for tangent, this is our tangent graph. This is what a tangent graph will look like. Do you guys see how this looks different than the other stuff that we've done?
Yes.
Okay. Tangents are vertical. Okay, it's a vertical like snake, like almost, looking like a cubic function. What you need to remember is that your asymptotes for tangent are always going to be the parent function. So for your parent, your asymptotes, let's see if I can remember how to spell it, for the parent function are at pi over 2 and negative pi over 2. That's very important information for you guys to memorize. When you are drawing a tangent graph, you have to have 4 asymptotes. This is what I'm going to look for. And 3, we'll call them snakes. You'll see what I mean by that in a second. Okay, that's what you need to worry about. So when you are asked to graph a tangent function by hand, okay? This is the first one right here. Graph a tangent function by hand. First thing I want you to do, when you see tangent, I want you to write down pi over 2 and negative pi over 2. And what did I tell you? You have to have how many asymptotes and how many snakes?
4 asymptotes.
Okay, so 4 asymptotes and 3 snakes. Whatever is with the x, you set that equal to your parent function asymptotes. Meaning, I'm going to say, okay, x over 2 equals positive pi over 2. And x over 2 equals negative pi over 2. This is how we're finding our asymptotes. So if I were going to solve for x, can we cross multiply?
Yeah.
Yes, if I cross multiply, I get 2 pi equals 2x, right? Yes?
Yeah.
Divide both sides by 2. So what does x equal? What does x equal? Positive pi, yes? All right, so over here, it's the same thing. Negative 2 pi equals 2x. Divide by 2. So x equals negative pi. Agreed? Okay, so there's 2 of my asymptotes right there. So if I'm going to graph this, I'm going to set this up. And I have an asymptote at positive pi, and I have an asymptote at negative pi. I have to find how many asymptotes?
4.
I got to find 4. Once you find the positive one, it's really easy to find the negative one. It's just a mirror image. How far is it, guys? How far is it from positive and negative? How far apart is positive and negative pi?
1. No.
To what?
Pi.
2 pi, right? You guys agree this is 1 pi here to 0, and then this is a pi here, so it's a total of 2 pi? Does that make sense?
Yeah.
Okay. So if I have an asymptote, I'm going to have one over here. I have one that's at pi. How far away does it have to be? What's the distance that I have to go? 2 pi, right? So what's 1 pi plus 2 pi? So I have an asymptote at 3 pi. So where's my other asymptote over here? Negative 3 pi. Good. So asymptotes. How would I draw an asymptote? Just straight dotted line, because my graph is going to get really close to that, but what? Not touch it. Good. So on your test, I need to see that you have your asymptotes at the right place. Positive pi, negative pi. And then I have a snake, right? I have my snakes. Well, how do I draw my snakes? Like a snake, squiggly. But where do I start? Is this positive tangent or negative tangent? Positive. So it's going to be what kind of a snake? An increasing one or a decreasing one? So literally, guys, draw a increasing snake. Some of you are like, where do I know to draw it? Guys, it has to be in between the asymptotes, right? Don't touch the asymptotes. Don't draw a straight line. I'm not going to be super specific on, oh, your asymptote is this, or your snake is this or that, whatever. It's like, yeah.
The first one is not squiggly.
It's not squiggly enough on the first one, yes. I'd like a little more squiggle. I need more squiggle. I need more squiggle. Yes?
I try to center on the X.
Right, we're going to do this again. What are we graphing? Tangent. So as soon as I see tan, a couple things I want to think of. I want to think of 4 asymptotes. I want to think of 3 snakes. And how do I find those asymptotes? What's the first? I need to remember pi over 2 and negative pi over 2. All right, what does that negative sign in front of this mean? It's a reflection. So my snakes, when I draw them, would generally go increasing, but since it's a reflection, I would draw them which way? Decreasing. All right, that 3 just tells you that it's skinnier. We don't need to worry about that right now. What I need to worry about is where are my asymptotes? So I'm going to say 2x equals pi over 2, and I'm going to say 2x equals what? Negative pi over 2. Everybody with me? We good? Okay. So if I'm going to get x by itself, what would I do to both sides? Divide by 2, which is the same as multiplying by what? No. 1/2. So this really is pi over 2 times 1/2, right? Which is positive pi over 4. Same thing on the other side, but it's going to be negative. Good. Divide by 2, divide by 2. So I have x equals negative pi over 4. Now, think about it, guys. I have how many asymptotes? Well, how many do I have right now? I have 2. How many do I need? Okay, so I have 1 at pi over 4. I have 1 at negative pi over 4, right? How do I figure out these other ones? How far is it from negative pi over 4 to positive pi over 4? It's 2 what?
Pi.
No. 2 pi over 4s, right? It's 2 pi over 4s. Correct. So if I start here at pi over 4 and I go over 2 pi over 4s, what is that tick mark on the right hand side? No, I'm starting at pi over 4 and I'm going over 2 pi's over 4. So I end up at what? 3 pi over 4. Wow. I know. That's why I just let you think for a second. So if I have an asymptote at positive 3 pi over 4, where's the other one? Negative 3 pi over 4. Remember, I need squiggle. So draw your asymptotes.
Do we get points on if we don't have squiggle?
If it looks like a straight line to me, then yeah. Not too much squiggle. I need just the right amount of squiggle. And it's negative, so that means what? It's going to go decreasing. Good. So I'm going to get close to my asymptotes, but not touch it. Good job. Okay? All right? Not bad? Not yet. Cotangent's easier, I think. Okay, cotangent. What do you notice about the way that the cotangent lines are drawn, or the squiggles are drawn? It's the other way. It's opposite. Your asymptotes. Okay, your asymptotes. What would we think about when we talked about asymptotes? When we talked about tangent, what were our asymptotes for the parent function? Pi over 2 and negative pi over 2. Okay, well, for your asymptotes for cotangent, you think of 0 and pi. That's why this one's a little easier. When we have a cotangent graph, we need 5 asymptotes and 4 snakes. It's easier, I promise. So, we're going to graph this by hand. First of all, I see cotangent. So as soon as I see cotangent, I'm going to write myself some notes. I'm going to say 5 asymptotes. What's up?
On
Of how many snakes?
the
4 snakes. And in order to find those first 2 asymptotes, I think of what 2 numbers? 0 and pi. Good. So same exact thing. We take x. I say x over 3 equals 0. And I say x over 3 equals pi. You'll end up doing that in a minute. So when I solve this, if I multiply both sides by 3, I get x equals 0, right? And then I multiply both sides by 3, and I get x equals 3 pi. So I'm going to draw. I have an asymptote at 0. I have one at 3 pi. How many did I tell you guys I needed?
5.
I need 5. This is why I think this one's easier. How far is it from 0 to 3 pi? Okay, so if I'm going to draw another asymptote to the right of 3 pi, it's going to be at what? 6 pi. Good. And then what are my 2 negative asymptotes? Negative 3 pi and negative 6 pi. So I'm going to have an asymptote here, one here, one at 0, 3 pi, 6 pi, right? And since it's cotangent, how do I draw my squiggle? The other way. We're going to go decreasing. So again, guys, it needs to be in between the asymptotes. Don't touch them. Does not have to be perfect, but something like that. Is that awful? The first one was because you had to add pi over 2. We had a fraction and we freak out. Okay, we okay? All right, 2 more things and then we're finito. When we talk about reciprocal functions, guys, sine and cosecant are reciprocals, yes? Cosine and secant are reciprocals. The way that you draw these graphs is the only thing that's different, okay? If you have a cosecant graph, you're going to think in terms of sine. You're going to do all the stuff that we've done before. And then when you actually draw your graph, it's going to be flipped. Okay? Look at this. This is my actual, where's my highlighter? This is my actual sine curve, correct? Right here? Right? So when they drew the reciprocal, when they drew the flipped version, do you see how each little interval, like right here, in between here and here, what did that green piece do? It just flipped upwards, right? Okay. What did the red piece do here? It flipped down. That's all that the difference is when you're graphing this. That's it. Same thing with cosine. So let me show you. It's not as bad as it appears. First of all, we're going to practice a little bit, stuff that we learned last week. As soon as I see cosecant, I think of what function? Sine. All right, so let's think about our sine curve. Our sine curve generally starts where? At the x-axis or the amplitude?
X-axis.
On the x-axis, okay. Good. Now, there's a lot going on in this. We have to identify the amplitude, we have to identify the time period, and we have to identify if something moves left, right, up, or down. So what is the amplitude here? It's 2. It's this number right here. The highest my sine curve is going to go is positive 2. The lowest my sine curve is going to go is what? Negative 2, okay? The time period. Remember, the time period is the number that's in front of x. So I'm going to take 2 pi and divide it by the number that's in front of x, which is what? So my time period is 2 pi. And then this last little thing. This is the thing that's annoying. What does this mean? What does plus pi over 4 in parentheses mean?
Oh, it's transformance, translation.
I get what you're saying. Where is this graph moving?
Oh, left.
Left. Very good. How much?
Pi over 4.
Pi over 4. So we have to do a little bit of computation first, right? If I was going to draw my normal sine curve, my time period that we're talking about is 2 pi. So when I cut it into 4 pieces, what are my intervals? What's the first tick mark? Pi over 2. What's the second tick mark? Pi. What's the third one? 3 pi over 2. Now, this graph shifts which way? Left. How much? So what do I have to do to every little tick mark that I have? Not multiply. I got to subtract because we're going left. Right? It's the opposite of what we think. So in order to get my new tick marks, I have to subtract 0 minus pi over 4. Right? Pi over 2 minus pi over 4. Pi minus pi over 4. 3 pi over 2 minus pi over 4. And then 2 pi minus pi over 4 to get my new tick marks. You guys with me? Okay. Good, good, good. So let's do some quick math here. 0 minus pi over 4 is negative pi over 4. Good. So pi over 2, if I change that to fourths, it becomes 2 pi over 4, right? So what's 2 pi minus 1 pi? Yep, so positive pi over 4. Here, if I change this to fourths, 4 pi minus 1 pi is 3 pi over 4. Good. Change this to fourths. 6 pi minus 1 pi is 5 pi over 4. Good. And then the last one. Change this to fourths. 8 pi minus 1 pi is 7 pi over 4. Okay, nothing new. We've done that before. So my new graph, when I go to set it up, that was a fantastic line. Wait. Okay, here's 0. Where's my first tick mark at? So it's going to be over here. Agreed? Okay. Then my second one is at pi over 4. Then my third one is at 5 pi over 4. And 7 pi over 4. Everybody with me? Okay, so now let's just plot it. We're plotting our sine curve. We haven't done cosecant yet. We're plotting our sine. So I'm going to start where? The amplitude is 2, right? So I'm going to start here. And then I go up here, x-axis, down here, x-axis, up here. Everybody agree? Yes? Okay. I'm going to draw this dotted because am I trying to graph a sine curve? What am I trying to graph? The cosecant. That is the sine curve. I need to graph, though, which one? Cosecant. So this is what you need to do. All of the places where the graph hits the x-axis. So right here, right here, right here. It's the way you can split it up. So in this area right here, does everybody see that this is where my sine curve would exist, correct? So if I flipped that, my cosecant graph would look like this. You guys see that? So So that's how you draw it. You do not have to erase the sine curve. But if you do this on your test, you have to make sure that your sine curve is dotted so I can tell that you understand the difference. So like in this second section, do you see how it's like a U? So what would the cosecant graph look like? The opposite. It would flip. It would look kind of like this. Right? And then this thing on the end here. It's only half, yeah. But do you see how it goes like that? So if I flipped it, it would go like that. See it? Not accurate. No, I mean, yeah, it has to be accurate, but it doesn't have to be perfect. So you go about graphing your reciprocals like you would a regular sine and cosine. At the end is when you actually physically graph is when you have to say, okay, since I want to do my cosecant, it has to be the flipped version. Does that make sense? A little bit? Okay, look at this one, this next one. This one's a little easier because there's no what? There's no shift left and right. Makes it easier. So the first thing we look at is this a what kind of graph? Secant, which goes with cosine. Think about that. Cosine starts where? On the amplitude. What's the amplitude here?
1.
Good. Very good. Your amplitude is 1. It's the number in front. So the highest and lowest that this goes is 1. How do you find the time period? The 2 pi. Good job. Divided by the number that's in front of x. So 2 pi divided by 2 is pi. There's no shift left or right, so we're good. So I'm talking about my time period of just pi. What are the little tick marks if I cut it into 4 pieces? Pi over 4. Then pi over 2. Then 3 pi over 4, right? My amplitude is 1 and negative 1. Where do I start cosine? At the amplitude, so it's going to be here, 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 here. I'm going to draw my dotted line, or curve, I should say, I'm sorry. Now, how do I figure out where to split my graph up to flip? Where it hits the x-axis, good. So, would you guys agree with me that my secant curve would be something like this? In the green? Yeah? Okay. Does that make sense? It's kind of, I get it. It's kind of a lot. Whoa, my bad. So here's our library of functions. This just kind of gives you an idea of what to look at. Our cosine and sine graphs. Right? Sine starts at the x-axis. Cosine starts at the amplitude. You have your tangent, your cotangents, our squiggles. And then we have our reciprocal functions. Right? So I'll post this video so you guys can look at it. Your test is when? Thursday. Okay, let's look.